Alright, another problem for you. So I'm doing the integral from 0 to 5 root 3 over 2 of 5x squared all over 25 minus x squared to the 3/2 power. You might be wondering, well, what does this have to do with trig substitution? I don't see an annoying square root to get rid of. Well, look at that 25 minus x squared to the 3/2 power. Well, let's use the properties of exponents. Rewrite this, 25 minus x squared to the 1/2 power, all cubed. Power to a power, they multiply. 3 times 1/2 is 3/2. Well, 1/2 power, that is square root. So I really have, on the bottom of my fraction here, I really do have root 25 minus x squared quantity cubed. Aha, I do have an annoying square root to get rid of. So I can't use trig sub here. All right. So let's see, I got this guy here. All right, so I'm going to start this problem by saying, well, I'm going to rewrite this guy as square root of 25 minus x squared cubed, like I just showed you. All right, so aha, now this looks like I can do trig sub. So I say, well, which identity does it look like? A number minus something squared. Looks a lot like this one, a number minus something squared. So this looks like 1 minus sine squared, but not quite. I got a 25 there, I want a 1 there. So if you use my approach, you say, okay, well, I'm going to factor out a 25. Inside that square root, I'm going to say, all right, I'm going to take this guy, factor out a 25 from it. So you can check and make sure I'm right. 25 times 1 is 25. 25 times x squared over 25. 25's cross off. Left with that guy. Okay. So now I can say, all right, well, the square root of 25 is 5. Now I got to be careful. This whole thing here is being cubed. So if I have that guy, if I have the square root of 25 times 1 minus x squared over 25, and I'm cubing it, well, if I take the square root of that 25 and say it's 5, then I am going to be left with this. So if I take the square root of 25 and say it's 5, well, then I got this whole thing still being cubed. 5 cubed is actually 125. So when I move on to my next step here, square root of 25 is 5, but if you cube it, you get 125. So here now is my integral. Square root of 25 is 5, cube it, 125, okay, and then over here, I said I'm going to take x squared over 25, I'm going to think about it as x over 5, quantity squared. All right, so moving on. Well, I say, okay, this looks like 1 minus sine squared, so I'm going to take this x over 5 here, and I'm going to make that sine of theta. So x is 5 sine theta. Dx d theta then is 5 cosine theta. I multiply both sides by d theta, and I get dx equals 5 cosine theta d theta. Now, we run into a little issue here, our bounds. These bounds are x values. But dx is going to change to something with a d theta in it. So I got to change these bounds from x values to theta values. So you got to say, well, what happens when x equals 0? Well, when x equals 0, plug 0 into here. 0 over 5 is the sine of theta. So you got to say, well, when is the sine of theta 0? That happens when the theta value is 0. At the angle of 0, sine of 0 is 0. Yay! So the bottom bound is going to change to theta equals 0. What about the top bound? What happens when x equals 5 root 3 over 2? Well, I'm going to take x there, and I'm going to replace it with 5 root 3 over 2. So when x equals 5 root 3 over 2, I'm going to get 5 root 3 over 2 all over 5. Well, the 5's will cancel. And you're left with sine of theta is the square root of 3 over 2. So you got to say, well, what angle theta has the sine value of root 3 over 2. You will want the angle pi over 3. Remember, we're looking for angles on the interval from negative pi over 2 to pi over 2. So that will become my top bound now. So the bottom bound is theta equals 0. Top bound is theta equals pi over 3. All right. I replace x with 5 sine theta. That means on top, x squared is 25 sine squared theta. All right, I replace dx with 5 cosine theta d theta. I replace x over 5 with sine squared. All right. So 1 minus sine squared. I'm going to change that to cosine squared. Square root of cosine squared will end up being absolute value of cosine. But I'm not going to need absolute values. So we could just see that by looking at the bounds here this time. Square root of cosine squared will be cosine because cosine is positive on the interval from 0 to pi over 3. Okay, so now I'm left with trying to find, do that integral. So what do we do? Well, all right. I got a cosine on top, I got cosine cubed on the bottom, cosines will cross off. I'm left with doing the integral from 0 to pi over 3 of 5 sine squared theta all over cosine squared theta d theta. Well, sine squared over cosine squared is tangent squared. Pull out the 5. I got the integral from 0 to pi over 3 of tangent squared theta d theta. Now, I don't know an antiderivative of tangent squared, but, so you gotta say, well, maybe a trig identity will help. Well, tangent squared plus 1 is secant squared. Subtract 1 from both sides. Tangent squared is secant squared minus 1. I don't know that antiderivative. I do know an antiderivative of secant squared. It's just tangent. Aha! So I'm going to take tangent squared. I'm going to replace it with secant squared minus 1. Great. So I want an antiderivative of secant squared. Tangent. Tangent theta. Antiderivative 1. Use theta. Now I want to plug in 0, pi over 3. So plug in pi over 3 is 0 and subtract. So tangent of pi over 3 will be root 3. I replace theta with pi over 3. Okay, so that's what I get when I plug in the top bound. When I plug in the bottom bound, I'll get 0. Tangent to 0, which is 0, minus 0. Oh, okay. So I'm just going to end up with 5 times the quantity, root 3 minus pi over 3. And I am done.